Okay, my friends, so I've got this thing set up to kind of model the situation where I watched Max 10 times. You can tell by the binomial probability right here, I'm assuming he's got a 50% chance of getting the shoes on the correct feet, because I'm assuming he's guessing. Now, assuming he's guessing means, as you can see right here, on average, he's going to get them right on the right feet 5 times. And that's because 5 is half of 10. But if you look at the probability of that 5 in this graph right here, or in the distribution over here, out of all trials where I watch him 10 times, that only happens 25% of the time. Because he's guessing, he's not going to exactly hit the average of 5. That would be like flipping a coin 10 times and having to get exactly 5 heads and 5 tails. As we've seen, that doesn't happen at all. Sometimes you get slightly more, slightly less. I couldn't help myself. I can't say something like that and then not do the experiment. So I'm going to flip a coin 10 times. You got a penny right here. You got the head side and you got the tail side. And I'm going to flip it 10 times. And we just saw in that distribution that roughly in a quarter of these trials, I should see exactly 5 and 5. Let's see what actually happens. Okay, here comes flip number 1. I just got heads. It's going to be kind of hard to see with the focus. So heads is flip number 1. I'll keep track up here on the video. Heads. I just got tails. Heads, tails. Tails. Heads. So 2 and 2 so far. Tails. 2 heads, 3 tails. I'm keeping track correctly. Tails again. 2 heads, 4 tails, I think. I'm going to go back and watch it. Heads, 3 heads, 4 tails. Heads, 4 and 4. Heads, 5 and 4. Heads, 6 and 4. So there you go. Again, there's only a 25% chance I'm going to get exactly 5 heads and 5 tails. That means there's a 75% chance I'm going to get something else besides equally split 50-50. So that time I got 60-40. But not really. I got 6 heads and 4 tails. Which, let's keep the video going now that we kind of illustrated that point. On average, it's 5. But here's the deal. That average also has a standard deviation. We can use those two together to set up some ranges. For example, as we just saw, the average happens about 25% of the time. You can tell right here, it's 24.6%, that's 25. If I asked you, if I watched Max and he got the shoes on the correct feet 4 times out of 10, is that close enough to average for you to believe he's still guessing? Most students tell me, yeah. They say it's not 5, it's a little bit below, but it's close enough. And I like the idea of close enough because if you look at the standard deviation up here, standard deviation is about 1.5. 4 is within 1 standard deviation of the average. And that, as you might remember from the discussion we had about standard deviation, would be considered kind of the typical range of values. As a matter of fact, if we consider 4, 5, and 6, the chance of those 3, if you look down here to the sum, that sums to about 65, almost 66%. And that should ring a bell to you. If you think back to bell curves, roughly 2/3 of the data lies within a standard deviation of average, which is about what we just looked at. So if we saw Max either getting his shoes on correct feet 4 times or 5 times or 6 times, I think that is well within the realm of guessing. If we extend it out to include 3 and 7, check out the probabilities now. They sum up, if you look down at the bottom here, to about 89%. Now we're starting to get into the regions on the far left and far right that happen rarely. And as a matter of fact, if we go out to 2 to 8, you can see down here that about 98% of the time, if a kid is guessing, they're going to guess correctly somewhere between 2 and 8 times. Now, I know the number that we've used for a long time is 95%. 95% of the time what happens, and that's within roughly 2 standard deviations. Between 2 and 8 looks like where the majority of the typical data would be. So if Max got his shoes on the correct feet between 2 and 8 times, and some of you, I know what some of you are thinking. You're like, you know what, Sean? 3 and 7, I believe that's close enough. But 2 and 8, that's pushing it. Well, that's fine. You might set your limit for normal as 3 to 7. Others might say 2 to 8. I don't think anybody is going to accept 0, 1, or 9, 10 as typical, though. I think once you get into those ranges, that's when you're like, okay, wait a minute, something's going on. Something is going on. And I do believe something is going on. We're going to talk about that in the next question.